All right, so for the first one here, we're solving x minus 5 for x. Now, this one is actually fairly straightforward, but it's a skill we're going to be using a lot later, as you'll see. In order to solve this for x, I need to move the minus 5 out of there. The opposite of subtracting 5 is adding 5. So I add 5 to both sides, we get x equals 5. Since it's x equals, that means we're done. So that's all we got to do for that one. Now for the second one, this is where I'm seeing the most problems and the most questions. This is going back to some stuff we did before, but it is one of those skills that quickly gets rusty. The very first thing we need to do, because I have these parentheses that are being squared here, is I need to get rid of the squared. What undoes squaring something? Square root. Yeah, absolutely. Now there is a little rule that we have to remember though when we take the square root of both sides. Remember that it's actually going to give us the plus or the minus there. Now the reason why we take the square root of both sides is because it cancels out the squared. So on the left side then we're just left with this x plus 1 because the square root canceled out the squared. On the right side though we do the square root of 4, which gives us 2, but notice we got that plus or minus in front of it. So we have to do it for both 2 and negative 2 because 2 squared is 4 and negative 2 is also squared equal to 4. And so we write each as its own separate equation over here and then solve each of those. And so to actually finish solving it out, if I have x plus 1 equals 2, then I'm going to subtract 1 from both sides. On the other one, it's also x plus 1, so I'm also going to subtract 1 from both sides to get my answers. You should be finding that x equals 1 and negative 3. The plus or minus there tends to be the hardest part to remember, although a few of you also had trouble remembering that square root part. So the thing to remember as far as the square rooting goes is that once you have something squared by itself, you have to get rid of the squared by square rooting. All right, so then on to our new material for today. Start by writing down this problem, and then we're going to walk through it step by step to see how we actually solve this. All right, now first up, I need to talk about what we cannot do in solving this. So I'm about to walk through some steps that are valid algebraically but not helpful. So do not write down this next part because I'm showing you what we don't do. Because oftentimes people's initial instinct with a problem like this is to make it x squared equals and then take the square root of both sides like we just did. But if you did that, it'd be x squared equals 3x plus 10, and then we'd be taking the square root of both sides, so x would equal the plus or minus square root of 3x plus 10. That's not actually helpful for us because you notice here I have x equals something involving x. I still don't know what x equals. I just actually created a more complicated looking equation. And so what we're actually going to need to do then is take a different strategy. And so that's going to be the new part that we're getting here. So the first thing we're going to want to do in order to actually solve one like this, and by like this I mean an equation that has both an x squared and an x in it. When you see that happen, step 1 is to factor the equation. So I need to factor this. That means I need to figure out what two numbers add to negative 3 and multiply to negative 10, because we're always adding to the middle number, multiplying to the last number. So what adds to negative 3 and multiplies to negative 10? It is negative 5 and 2. Yep. And so that's the first step we do, is we factor it down to be that. Now that we've factored it, we can actually go about solving it. And I'm going to show you why this works after I show you what we do. The next thing we're going to do is we're going to take each of those two sets of parentheses and we're going to set them each equal to 0. So in this case that means we're going to do x minus 5 equals 0 and we're going to do x plus 2 equals 0. So add that to your work on your paper there. And then having written those two smaller equations, I can now solve them for x. I can solve them for x at this point because you'll notice each of these two equations just has a single x in it. I no longer have two x's in the equation. Each one is just one x. And so I have x minus 5 equals 0. In order to solve that, I'll add 5 to both sides, just like we did in the warm-up. And for the x plus 2 equals 0, I'll subtract 2 from both sides. And so then we end up getting that x equals 5 and x equals negative 2. And that's the final answer. Now, I did promise that I'd explain why it works the way it does here. So why does it work? If I plug in x equals 5 here to illustrate why, notice if x equals 5, that's one of my solutions. If I plug that back into my factored form here, I plug in 5 for both of the x's. 5 minus 5 gives me what? 0, which is a good thing, considering that's how I got the 5 in the first place, right? Because I was solving what makes it equal to 0. So if that equals 0, 5 plus 2 happens to equal 7. But no matter what that other parenthesis equaled, it could be 7, it could be 21, it doesn't matter what that other parenthesis equals, because 0 times anything is 0. And so the reason why we take each of these two sets of parentheses separately and set them equal to 0 is because they're multiplying by each other. And if I make one of them 0, 0 times anything is 0. And so I just make each one equal 0 and we're good. Now I happen to use the example of x equals 5 here. You could prove the same thing by plugging in the x equals negative 2. That would give us a number here times 0, and anything times 0 again would still give us 0. So that's why it works the way it does. Now I'd like you to write down this problem and go ahead and solve it using the same method that we just walked through. So just like the last problem, your first step is to be factoring. So factor that. In this case, that means what adds to 4 multiplies to negative 21. So we get 7 and negative 3 here, because 7 times 3 is 21, and since it's a negative 21, we got to have one of them that's positive and one of them that's negative. I know which one's positive and which one's negative because I'm adding to a positive, which means I have to have more positives than I have negatives. So the bigger number is the positive. All right, now to finish solving this out, once it's factored, I take each of those parentheses and set them individually equal to 0 and solve each of those. So that means that in the case of the x plus 7 equals 0, I subtract 7 from both sides. In the x minus 3 equals 0, I add 3 to both sides. And so your final answers here are x equals negative 7 and x equals 3. Yes, I do want you showing these steps and showing this work. It's laying a nice firm foundation for later work that you might see that gets more complicated, and it helps you understand why it works the way it does. Next up, I'd like you to solve this equation. Now, before you get too far into this, I want to make sure that you're approaching it the right way. Because there are two different ways you can do this problem, but one of them tends to be much easier than the other. We could, but do not have to, actually do the x minus 5 squared and multiply all of that out. Well, that is a valid method for being able to do this. It certainly is not going to be the most useful. Because instead of doing it that way, I could actually start this problem by subtracting the 1 from both sides, leaving me with x minus 5 squared equals 9. This is actually a problem like the ones that you had done before today. With us learning a new method on how to solve a quadratic, I don't want to push out the old learning. I want you to still remember how to do this. And so since it's x minus 5 squared equals 9, this is the one where I can take the square root of both sides. And when you do that, remember the plus or minus. Now, as you finish solving it out from there, a little clarification. How did I know I didn't have to factor it in this case? Because the last one I had to factor it. Why don't I in this one? What tells me that is the number of x's in the original problem. Notice in this original equation up here, the x only appears once. That means I can solve it just by moving stuff side to side. In the last two problems that we did, we had to factor it because we had both an x squared and an x. And so since there were two separate x's in the equation, that's what told us to factor it. All right, so let's finish solving this out now. When I take the square root on the left side, it just cancels out the squared, so I'm left with x minus 5. The square root of 9 is 3, and again it's plus or minus, so I got x minus 5 equals 3, and x minus 5 equals negative 3. solve each of those, which means moving the 5 over to the other side. So if I add 5 to both sides on both equations, I get x equals 8 and x equals 2 for the final answer. The last problem I'd like you to do now today is this one. X squared plus 11x plus 30 equals 0. Please solve it. And so the first question you should be asking yourself after you write it down is this a problem that we're going to have to solve by factoring it? So, will we have to factor this one? The answer is yes. Why do I know that? Because it has both the x squared and the x in there. Whenever you see both of those, factor it. Our factored form in this one, adding to 11, multiplying to 30, it's going to be 6 and 5. And so then I take each of those parentheses and set them equal to 0. On the left side, that means I subtract 6 from both sides. And on the right one, I subtract 5 from both sides. We should be getting x equals a negative 6 and x equals a negative 5.